All right, let's start off here on section 4.1. We're first going to do some vocab. So we got exponential growth, first of all, is an exponential function where the graph increases, or you could say grows there. From left to right, it occurs when the base of the exponent is greater than 1. And then conversely, exponential decay is where we are decreasing. And then that's always going to happen when the base of the exponent is less than 1. And then last we have our natural exponential function, which is defined right here. And this one is f of x equals e to the x, and where e is the irrational number that is about 2.718. All right, steps for graphing the rational function. There's a lot of different ways to do this. I kind of always start with a couple of key points here. So I always start with a 0, 1. Actually, every exponential function has that point. And then if it's in the form kind of b to the x. And then the next one, it would be 1, base. And I kind of just think of these because obviously if I plug in a 0 in for x right there, the 0 power turns every base into 1. And if I plug a 1 right there, I'm just going to be left with whatever the base is. Every exponential function also has a horizontal asymptote, and it always starts off at y equals 0. Okay, and then the other thing we have to keep in mind here is just the transformations that we've kind of always been seeing throughout the year. So we need to apply those accordingly. All right, so number 1 here, I'm just going to start off with my key points. I got 0, 1. I got 1, base. In this case, the base is 2, and we got a horizontal asymptote at y equals 0. And then there are actually no transformations on this one. For the transformations, we're going to be looking for adding or subtracting or kind of multiplying going on. And we don't have it here, just kind of the base of 2. So I'm going to put my point there at 0, 1, 1, 2. And I got my horizontal asymptote at 0. And then we can draw our graph there, the little exponential growth. All right, next up here, we got number 2. So this one, we'll start off again with 0, 1, and then 1, base. In this case, our base is 1/2. And then we're going to start off with a horizontal asymptote of y equals 0. Now, in this case, I do have some transformations, so I'm going to look at them here. I see I have an x minus 1 in the exponent. Now, whenever it's in the exponent, that's a left or right shift, and it's the opposite of what you would think. So this is actually going to shift it right 1. It's just an x lies type of thing. And so then this minus 3 outside is going to be a shift down 3. Anytime it's adding or subtracting outside the exponent, it's going to be up or down. And so what I'm going to do here is I'm going to apply these transformations. So I'm going to say for this one, I'm going to add 1 to my x's because that's going to make it go right. And also, since it says x minus 1, once again, x lies here. And I'm going to subtract 3 from my y's, and that's going to move it down. So this point then will turn into 1, -2, just applying those rules that I set out right there. So I'm going to add 1 to the x and then subtract 3 from the y value. So I'm going to call that -2.5. Now, my horizontal asymptote, you can see, is a y value, and so I am going to apply the y transformation there. So I'm going to make that -3. So my asymptote gets moved down to -3. You're going to see that this does always shift with that adding or subtracting out back. And then I got my other 2 points there. 1, -2 would be here. And then 2, -2.5 would be right there. And so this one will create an exponential decay. As you can see, the points are decreasing. Also, we know that because of the 1/2 in the exponent. Or sorry, 1/2 in the base. When that's less than 1, it's going to be decay. All right, next up here, number 3. And so for this one, we're going to start off with our point at 0, 1, and then 1, base. And then our horizontal asymptote at y equals 0. Now I'll apply my transformations here. So I have this +1 here, which is a shift up 1, which means that I'm going to my y values, add 1, because y tells the truth. Now this one right here, actually, let me do this in a different color. So this negative right there inside the exponent, that's going to be a y-axis reflection. That's going to affect the x values. I'm going to make all my x values negative. I know that we always think about x lies, but in this case, it's kind of like that's multiplying by a -1, and I'm going to divide the x's by a -1, so it does come out just as a negative x. Now, obviously, there's no such thing as -0, so I'm going to keep that one the same. But this one I need to turn into -1, comma 4 to add 1 to the y values. And then lastly, I got my horizontal asymptote. I'm going to move that up 1 right here. Okay, so we've got our horizontal asymptote right there. And then 0, 2, -1, 4. And so this one is going to be decaying. And I know it looks like it should be growing because we have that 3 in the base, but because of the y-axis reflection, because that -x, that does switch it. All right, number 4 here is written a little bit weird. I actually kind of more think of this as -2 times 1/2 to the power of x plus 4. That's just, I like that adding or subtracting part out back, and so I'm going to keep that in mind as I do my transformations here. Now, I'm still going to start with my 0, 1, and 1, base. My base here is 1/2, and my horizontal asymptote at y equals 0. Now, I actually don't have any transformations in the exponent, so that means my x will not change here, all of my x's, so I can just write those right away. But I do have a lot of transformations for y, so this is going to be, it's going to be a vertical stretch, and it's also going to be a reflection because of the negative, and then I have an up 4 shift. So all of that's affecting y, and so I'm going to write a formula here for y for everything outside, which is multiply every y value by -2 and then add 4. So I'm just going to do that in PEMDAS order here, just following along with these two numbers. This -2 is multiplying, this 4 is adding. So let's see, 1 times -2 plus 4 would be 2, and then 1/2 times -2 would be -1 plus 4 is 3. And then for my horizontal asymptote, I need to apply that as well. So 0 times -2 plus 4 is 4. So I got my, my horizontal asymptote right there. I got a point at 0, 2, a point at 1, 3. So it is going to approach the asymptote going that way. All right, next up here we have our natural exponential function with the base of e. And so I'm just going to do this the same way. So we're going to start off with 0, 1, and then 1, base. For the base here, I'm going to use about 2.7. It's kind of an estimate there, but it's kind of going to be close enough for our graph. And we'll start off with our horizontal asymptote at y equals 0. And then my transformations, I have x minus 1 for that plus 1 up there. We do the opposite. And then I have y minus 4 for the minus 4 out back. So then it's going to turn into -1 and 0 for my x's, and then for my y's, it'll be -3. This one will be -1.3, and then this one, the horizontal asymptote, will move down to y equals -4. All right, so I'm going to put that down there at -4, -1, -3, 0, -1.3. Oops, that's there. And so this will be some growth going that way. E, 2.7 is greater than 1, so it's not that surprising that we have the growth. All right, next up here, another natural exponential function. So we'll go 0, 1, 1, 2.7 we'll estimate. And then our horizontal asymptote at y equals 0. And then our transformations for our x values, we need to subtract 2. And then for our y values, I have a negative out front and a plus 3 out back. So I'm going to do -y plus 3 to take care of both of those. So my x values, I'm going to subtract 2. My y values, I make them negative and then add 3. So -1 plus 3 is 2. -2.7 plus 3 is 0.3. And then -0 plus 3 is 3. So I got my horizontal asymptote at 3. -2, 2, -1, 0.3. So that's going to be looking like this.